Again, we are trying to find the volume when you rotate about the y-axis. It will usually be 360 degrees. Later, I will show you questions that are 180 degree. Okay, but for now, no need to complicate things. It will always be 360 degree. There are three positions that you should learn on how to cut your diagram. So if you're rotating y-axis, you want to cut the diagram on the extreme ends first, which means the lowest and the highest. We start with that so that it will be clear what limits you're going to integrate to. When I say extreme ends, I'm referring to the lowest position here is at 0. The highest position of my shaded region is here at square root 2. Lowest to highest, we mark it out first. In between, I would like to check, are there any intersection points between your curves? Now, this point here is considered an intersection. It's an intersection between the curve and the vertical line. This is considered a curve. This is a vertical line. So there is this point here which I would like to cut the diagram up one more time. Okay, we chop it here at the middle. And number 3, you would like to look for any y-intercept. Okay, so there are two regions. This is number 1, this is number 2. Y-intercept, we don't need to further take care of it because there's already a cutting here. This is our lowest point. Why are we splitting it into two regions? Let's say we are looking at region 1. There is this gap here. Region 2, there's also this gap towards the y-axis. We are rotating on the y-axis. So if there's a gap appearing, we will identify that there is an outer curve. Okay, this is the outer curve for region 1. It's further from the axis compared to, let me mark out in green, this line. Okay, region 1, this is the further curve. This is the nearer curve. Okay, so my outer curve is regarded as x equals to 2. It's a vertical line, x equals to 2. This is the inner curve. And we prepare and make x the subject first. You will get a y over 2. Okay, so the region 2 above will be, this is now the outer. This is further from the axis. This is the outer curve. So this is x equals to 1 over y. And this other curve here is your inner curve, for which we have the equation. I've prepped for that. It's the same curve as y over 2. Okay, so now let's fill in the volume required. I'm going to treat it as region 1 and 2 separately. Okay, let's start with region 1. Your limits will be 0 to half. You're looking at the y values. We go for x squared. Formula is x squared dy. So x squared is 2 squared outer minus inner. So inner is y over 2 dy. X squared dy for the formula. And my second region is half to root 2. Outer is 1 over y squared. Inner is the same. It's y over 2 squared dy. Okay, for the simplification, let me skip that. Now for the right diagram, I'm still using the same two curves, but the shaded region is different. We're still going to rotate the y-axis. Can we cut the diagrams at similar positions first? Always check the lowest to the highest position so that we know the limits. It's half to 4 in this case. In between your lowest to highest, we check whether there's any intersection point, which there is. This is an intersection between the two curves that you have. So now there is a region 1, region 2. Your rotation axis is the y-axis. Does your shaded region touch the y-axis? Okay. It doesn't for both of them. There are gaps appearing. So whenever you have a gap between your shaded region to your axis, we identify there is an outer curve. The outer curve is actually the same one throughout. This is your outer curve. Versus there is also an inner curve. But the two inner curves are slightly different. This is your equation, y is 1 over x. So for this inner curve, you make x the subject first. We plan for it. X is 1 over y. Region 2 inner curve is that straight line, which is x is y over 2. So different inner curves on both regions. And we now write down the volume that we want. Region 1 will be half to root 2. Outer is a vertical line, so you have 2 squared. Okay, minus inner. Okay, outer minus inner. And we add it up to region 2. Outer minus inner squared.